Okay. So I'm Mary Schlembach here with my colleagues and Alex and at the University of Illinois to discuss our project on the research impact indicators visualization and analysis. And as we all know, bibliometric research has been impacting services within libraries for hundreds of years. And we're also trying to establish bibliometric and research impacts by partnering with other campus units to gather and analyze things such as promotion and tenure, grant requests, and overall program evaluations. This might be a little controversial for people that, you know, wonder why the library is involved with their evaluations and their output, but we've been asked to do this, at least at Illinois. So libraries are using these impact tools such as abstracting and indexing services, vendor APIs, and we are starting to use visualization software and expertise in scholarly communication. As we know, there's a lot of research on literature on research impacts, and historically that has focused on citation data and the number of publications of that citation data. So we are now trying to do new quantitative measures which are being applied and in visualizations for how this all fits together and looks cohesive as one big package. So we were first concerned with responsible research methods, metrics, and we looked at different variations. We are focusing on the 2012 Declaration of Research Assessment, or DORA, which evaluates output evaluation, which has improved ways of researching scholarly outputs, and the 2014 Leiden Manifesto, which focuses on base 10 principles on research evaluation and has more of a focus than does DORA. We're also looking at I-norms. We have a controversy if it's in-norms or I-norms. It's for pronunciation of the acronym Research Evaluation Working Group. So one of the things that we considered at Illinois, in addition to the citation data, is a multi-tiered indicator with a matrix approach. So we are looking at articles published by the researchers, of course, but the overall impact factor of those journals using CiteScore, ISI, JCR, SNP, and the eigenfactor. The usage downloads of the journal, that's our local journal utilization report, so it shows the impact specifically on our own campus. The alt metrics or attention scores of articles, and within science and engineering, of course, the position of the author list being last author is usually the main author of that type of publication. And also the acceptance rates of journals or conferences. The conference acceptance rate is particularly important in computer science fields. We, of course, are looking at the number of times cited, but also the impact of the citing journals and the time cited of the citing articles and the number of citations by year. In addition, we are also looking at the number of grants received by those researchers, and then in the United States, of course, that's the National Science Foundation, the National Institutes of Health, and the Department of Energy. Other things that we are looking at is patents. We consider that kind of a best measure of innovation, and we are using the USPTO Patent View API and database. We're also looking at the National Academy memberships, AAAS, and things as Nobel Prizes. Startup companies, we have a research park on our campus, and there's also affiliated with some other nearby science and engineering schools like Purdue in Indiana. And the intellectual property associated with license agreements, of licensings of material or research that's worked on campus. We're also looking at the number of co-authors and the prestige of those co-authors. And within NIH grants, the cohort of a group of co-authors within a specific discipline. We're also looking at the leadership, sometimes called the voice or the quantitative measures. And some of these we haven't quite implemented yet, but we're looking at future implementations and how we go about doing this. Okay, so at Illinois, the library is involved in providing interactive research visualizations and dashboards departments. We started with the Cancer Center of Illinois, which is a relatively new research center, and they wanted to see how they were working with collaboratively with each other and with outside cancer research institutes. We are using the Elsevier Scopus API and SciVale Experts API scripts to drive those visualizations. We started out with one table of the names and the Scopus author ID numbers. Since we've developed this more with other departments, and we now have library graduate students who do all the work on developing those tables so they get a basic understanding of how this works together. And then we do additional scripts to create co-authors, grants, and patents, and cited by tables. I'm going to show you some displays of those in a little bit. So it's all database driven and interactive and web-based, and it provides different visualizations for the individual research groups at the departmental level. We did make sure that it's a clickable display bubbles and research impacts for each individual users. And we also have custom built grants of NSF, NIH, and patents. And this is all employing the server-side scripting, scalar vector graphics, HTML, and JavaScript. We also looked at other software, but wanted this to be interactive. So we looked at Tableau, Voss Reader, Gephi, R, and some others. But we, like I said, we wanted to have it be more interactive, web-based capabilities, and being able to work with discrete databases for the visualization. We wanted the ability to produce custom database tables and have indicators across multiple departments. That would show the interdisciplinarity between different departments on campus and outside within the research groups. We wanted the ability to perform custom correlation analysis and display in the different renderings of displays, and I'll show you some of those too. Okay, so like I said, we started with the Cancer Center NIH grant. Now we've adapted this for 9 other departments on campus. And like I said, we've had graduate students now doing the coding of the faculty and Scopus author IDs. Some of the research indicators displayed and are clickable are the articles published in the designated specific time period, so 8, 10 years, whatever the department wants. Aggregate journal impact total using the site score metric, so overall journal impact factors. Of course, the number of times the above articles are cited, the number of NSF, NIH, or DOE grants, number of patents received, number of and list of co-authors, and custom co-authors with the cohort visualization. So this is an example of the visualization display. This is our bioengineering department. Each person's name is at the top, and the purple bubbles are the number of journals and our journal articles with the journal impact factor, and the darker green bubbles are the number of citations. The pink bubbles are grants, are kind of the peachy color ones, and the pink ones are in the number of co-authors. The sage green, that sometimes a lot of them don't show up, are Stephen Bopart has 24, and Rohit Pragarva has 7 patents. So you might see some that don't have any patents at all. This is a bigger display of that, so you can see this better. And I'll let you look at this for a minute. So each one of these little bubbles or blue font is clickable, and then I'm going to show you what these look like as a specific search result. So this is Rohit Pragarva's journal article display, and as you can see, it has the site score of the journal, Nature Protocols. Down at the bottom, it has a link to the full text, and the number of citing article references that increases as on the fly as things come up. And then also, of course, the Scopus record with the references used, and including the abstract and all that. So you'll see this is 151 results. So this is actually, and we can sort the display in whichever way they want, chronologically, reverse chronologically, or time cited. So this is just the first hit that from Rohit, and started in 2014. Okay, so this is our display for the group co-author display, and we're going to use Rohit. That's an example here. He's got the 82 articles, and then these are the other departmental people on our campus that he's co-authored with. The little blue number with underscore is the number of articles that he's written with each one of those co-authors. We've also done some displays for specific research groups that are written over the Scopus API metadata database to generate visualizations. We provide this to the actual people, departments and things like that, so they can do searching and create their own visualizations. So this is an example of the Cancer Center at Illinois faculty publications, and there's things that they can search them. Okay. So, and this is an example of the grants bubble. When you click on the grants bubble, then you get a list of all the grants that the person currently has. We haven't, since we're doing this on the fly from the granting applications, we don't have former grants or grants that have expired. So Rohit has 4 NSF grants, 23 NIH grants, and then you can see how much the grants are and the time that they were run for. This is an older screen dump. Okay, so one of the things that we wanted to make sure of was that the visualization, and this is the reason why we use these various APIs and software, was that we wanted it to scale to various displays. So this is an example of our visualization wall. It's a 16 monitor, I can't remember the exact dimensions anymore, visualization wall that we have in our research area of our library. And then you can see, and you can click on all those screens, our touch screens. But that's Amy. She's one of our former grad students standing there in front of the viz wall, so you can see approximately how big this was. But of course, this does scale to tablets and regular computer monitors, of course. Okay, so we're going to talk about the our experience with this and what this has come and what we've been able to do as far as research on individual researchers. So the work enhanced the role of the librarian. It was created some foster, sorry about that, campus partnerships. And we are using the same scripts and display softwares for all research groups focusing on science and engineering. We have 2 follow-up studies, and that's examining the correlations between various research impacts and the mechanisms for weighting and generating research impact. We can evaluate whether researchers with the most articles have been, whether or not they lead to the highest cited items, highest H indexes, most patents, and or most grants. We performed a correlation analysis over 360 of our Illinois researchers from the past 8 to 10 years and found correlations between the number of articles with an H factor in Pearson's R of 0.59 on the wrong slide, and time cited to be 0.551. But unfortunately, well, fortunately, this does illustrate the known issues with younger faculty researchers and how the H index is unfair to them because they don't have the breadth of research for the higher citations in order to measure the H index and within when they have less than 5 or 10 years of experience. Other correlations that we've found is the number of articles and time cited. So we have, but this is a variance across various departments and with the Pearson correlation of 0.89, which is significant in most cases. The cite score and the number of articles written is Pearson 0.836. Grants and articles is relatively low at 0.204. Patents 0.193, and patents and grants, which is interesting, at 0.388. These results show that grants and patents awarded are useful alternative metrics in evaluating research impact and innovation. We're also looking at weighting of indicators and generation of composite research scores. We have developed as a weighting select research impact indicators and dynamically determine the research composite score for individual researchers. This allows for direct emphasis on different criteria for different departments. And the next version we're working on is to allow varying visualization displays and weighted information. So I'm going to show you what that screen looks like. So here, it lets you put in how much you want the specific indicators to be weighted at. So articles, for example, are 80%, each index is 6, and that type of thing. So when I'm going to show you the results here, this is also bioengineering. The display here is with the composite weighted number, their total number for each person. Currently, this is sorted alphabetically by researcher's last name. We're contemplating whether or not it would be advantageous to sort by the weighted composite weighted number. Oh, that was the last slide. I've forgotten that was the last slide. I don't know how much time we have. If we have any questions.
Well, we have just a few minutes for questions, Mary. Thank you for that. First question, what was the visualization tool you used to create those bubbles?
That's hold on. That I don't recall. I kind of do the background database work with the GAs. I don't do the scalability, but I know it's server-side scripting and it's scalar vector graphics in combination with HTML and JavaScript. So it's a combination of all those types of software programs.
Okay, thank you. Thanks, Mary.
Thank you very much for the excellent presentation, Mary. I have a couple more questions that came. The first one, how are the teams identifying prestigious authors, and do they see any dangers in that?
Well, the prestigious authors is actually, in a lot of ways, what we've done is kind of had the department determine that. And so if your department's, we're not determining that. We're basically saying, we're looking at the overall, their publications, their impact within the department. And then their department is basically department heads or, executive committees are more or less deciding on who's prestigious. We're very much like not in the labeling, category. We don't. That's not our call. So, and if there's problems with that, then if someone considers themselves prestigious, but their department head or whatnot doesn't, we can kind of, not our call. Does that help understand that? We're just given the numbers that are out there. And that's a really interesting question. I have had somebody come back and say, well, my numbers are higher than this, and we need to take a take a look at this. And so what we do is we go through all their publications, look at all the things across the different databases, ISI, Scopus, that type of thing, and then correct any anomalies within those indexing databases if we find. Which
Thank
helps.
you.
Yeah, no problem.
And related to this, do the teams see any conflict between following DORA and displaying journal site scores?
We are still working on that type of thing, so we haven't found anything specific yet, but we probably should do an analysis of that as well.
There is another follow-up if the faculty members can say no to their metrics being put on display.
We haven't had that come up. Most times, that's actually an interesting question, and we haven't had that come up. I'm not sure how. I mean, when we get asked to do this, for the most part, it's by department heads or a research group. It kind of the head. They want to see, kind of what's going on, and so we haven't had anyone come to. We haven't had anybody come to us and say, no, I don't want to be a part of this. I don't think it would show collegiality if they did, but that's a really interesting question to see if that would ever come up.
Yes, and the very last one, because probably this is all that we have time for. There is quite a lot of backlash against composite indicators in the responsible metrics community. Do the team see any problem with this?
Once again, no, we haven't had anyone be that negative about this. It's more of a productivity tool so that because I think a lot of times what they're doing is, we're showing these really huge numbers of citations and really huge numbers of innovation and things like that. And they're taking that to the campus level administration and kind of turning it, saying, okay, this is what we've been able to do. And it's more spin it as a more positive than a negative. So once again, we haven't had the negativity. This has been mostly positively received.